Hello everyone, I'm Sanan Garev and my dissertation project is on the topic of cross-embodiment learning in vision language action models under the supervision of Professor Sheng-Chu Zhou. So when we look at the vision language action models in general, the training paradigms is divided into three main parts. It's just like the LLMs like ChatGPT. So the first step is the pre-training phase where we are collecting large-scale internet video data, and also we are using the large-scale cross-embodiment data like OpenX embodiment, and we are training the model to predict the action tokens. So basically, the model is trained for so long time, and regardless of cleaning, the datasets involve too much noise. In the second phase, we are fine-tuning the model for more specific tasks like cleaning kitchen, cutting apples, putting fruit to bags, etc. We use the clearly collected in controlled environments, like clearly collected less noise data, and we are also using the simulation benchmarks, and we are collecting the data from the simulations as well to fine-tune the models. Finally, there is also the third step that's not being used that much right now, but probably will be used in the future. And it's mainly on the kind of RLHF system in the ChatGPT. It's used to reduce the risk of failing. And as we know, the human teleoperation can be very noisy in some cases. So this system makes the robot learn on its own on the specific tasks, but giving the background from the VLA system. Let's analyze just quickly how the NVIDIA's GR00T N1 model works. So this is one of the most famous VLA models for the humanoids. So as you see, we are collecting the humanoid data, also human hand data, and we are feeding the image observations, also the language prompts to the VLM phase. As you see here, it's using the pre-trained VLM, which is eagle-2 VLM in this case. Then we are using the diffusion transformer and feeding the robot state and noise actions to generate the actions using the action decoder. So the main aim of the diffusion transformer in this case is leveraging the different levels of noise on the action space so that the model is getting adapted to different environments. In general, the cross-embodiment learning can be divided into four main groups. First group is the robot-to-robot learning, like from one type of manipulator, we can transfer this knowledge to another type of manipulator. Then we can do the same thing with the grippers. So from one type of gripper, we can transfer that to another gripper. Then in the literature, there are so much like review on the human videos to robots, physical robots, and also the simulation to real gap can be collected in the cross-embodiment learning. So what is the problem? So the problem is that, so in the general models like this, you see that when we have the pre-trained model and when we have the new robot data set, but the robot's embodiment is in the pre-training stage, so it's much easier for the model to learn it and to adapt it for new tasks. So we are just using the collected data sets, like with less noise, and it works. But what if we have a whole new embodiment? So the problem is that when we have the whole new embodiment, like a new robot or new manipulator or etc., when we feed this information to the model, for the model to learn it much better, we have to feed too much data, like hours or thousands of hours of video data sets. So can we transfer the knowledge already learned with one embodiment to the another one, like from one manipulator to another one? Or more specifically, can we leverage the actions learned by like low-cost robots like SO101, as you see on the slide at the left side, to the more complex and expensive manipulators like Franca, humanoid G1 arms, or other type of manipulators? How can we approach this problem? So in my mind, to approach this problem, I am trying to dig into the literature for these topics. So I think that fine-tuning strategies for vision language action models can make the models learn faster and in a more efficient way, which can also be used for using the less number of samples for the new embodiments. So cross-embodiment learning is not a new topic. It's being used in the imitation learning scenarios. And finally, the data curation techniques like data normalization, etc. These kind of techniques are seen to improve the efficiency of the models too much. So the next steps include the teleoperation. Like I am using the RoboCasa benchmark for now. In the Robocasa benchmark, we have the different type of manipulators and the humanoid arms. But the teleoperation in this Robocasa is pretty huge problem. So I aim to include the cheaper arms like SO101 to this kind of simulation platform and use the mirroring approach instead of inverse kinematics, because inverse kinematics sometimes can result in very weird actions or movements of the manipulators, but the mirroring approach solves this problem. And this kind of thing can create a baseline for further cross-embodiment adaptation research. And on the second side, in the meantime, I'm trying to understand how the knowledge can be transferred from one embodiment to another embodiment. Here, I'm trying to focus on the latent action space, which is the representation of the actions in a different way so that all the manipulators or the robots can understand it. Also, additional diffusion models can be adapted to transfer like one type of robot's image to the other one with the same action space. Thank you for listening.